Assalamu alaikum dear students. In today's lecture we discuss the remaining problems of the Marion books. Let's start question number 4. What the question number 4 says: a clone is juggling, mean this is some type of juggler. A 4 balls simultaneously. Students use a video tape to determine that it takes the clone 0.9 second to cycle each ball through his hand and to be ready to catch the next ball. What is the minimum vertical speed the clone must throw up each ball? This clone is some type of juggler, means one who magician. You consider it like a magician. He is juggling the ball like in this fashion that 3 balls at one time. 3 balls will be in air and 4th ball is in hand. When he throw this ball, and other ball which is at 4th position come in his hand, and similarly when he will throw this ball, and this the third one ball will become in his hand. Similarly, at any time 3 ball will be in air and the 1 ball will be in hand. So he maintained the time difference in such a way, then all these successful circulations make possible. So what the question asks: what is the minimum vertical speed the clone must throw up each ball? So for successful circulation of these ball, what should be the vertical speed that should be given to this ball for this circulation? So we need to first, we are given some time some data that first of all he tells us that students use a video to determine that it takes the clone 0.9 second to cycle each the ball. Each ball takes 0.9 second, means if the ball is projected from here, then it takes 0.9 second this ball to complete one circle to again come in his hand. So time of flight for vertical case can be found. We can see that time for flight is 2v0 sin theta over g. So here sin theta will be 90 because he is projecting ball at angle 90. So sin theta will be 1. So we simply can write our expression like 2t is equal to 2v0 over g. As given time to cycle the ball, for one ball it complete the circle in 0.9 second. We have 4 ball. If 3 balls are in air and the 4th ball is in hand, so how we will manage the 4 ball? For successful circulation, 3 ball must be in air and 1 of the ball must be in his hand. For 3 balls in air, time will be equal to 3 time of 3 ta prime, where ta prime is 0.9 second. For 1 ball time is 0.9 second. So for 3 ball time will be 0.9 multiplied by 3. So this will be 3 into ta. So for successful negotiation, if the time of the ball which is in hand, which is equal to t in hand, should be greater than or equal than 3 time of ta, because when a 4th ball come in his hand, the first ball should leave his hand. So for successful circulation of the ball by the juggler will be if t in hand, time of that ball which is in hand should be greater than 3 time of ta prime. Ta prime is the time for that ball, which for one ball to complete the whole circle, which is 0.9 second. So we are given t prime. If we substitute value for t prime, and again this highlighted color like t ta prime, this is 0.9 second. So this will give us this velocity. If we put this time here, so this will give us the expression 2v0 over g is equal to 3 cross 0.9, and so we can find here v0, the vertical speed which should be given to the first ball which is in hand, so that the other 3 balls stand at air. So at this velocity, whoever is successful, negotiation will be possible in air. Another question is, a particle is projected with initial velocity v0 up a slope that make an angle theta with the horizontal. Assume frictionless motions and find the time required for the projectile particle to return to its starting point. Find the time for this data also. So first, if we are projecting the ball along the inclined plane, then we should have an idea that what amount of frictional force act on this. So frictional force or inclination, this mg sine theta force, a particle is projected with initial velocity up a slope that makes an angle theta with horizontal. Assume frictionless motion. It means there is no friction. If there is no friction, then the one component of the force, the gravitational force, mg sine component, which acting always in along the inclined plane, mg sine component, so this will act along the inclined plane, mg sine theta. If we find acceleration, so acceleration will be force over mass, so m will get cancelled with m, so we will left with g sine theta. So acceleration in this case will be g sine theta. If we use first equation of motion, vf is equal to vi plus at, because if we are projecting this ball up the plane, at the highest points its velocity will be 0, so we put final velocity equal to 0 and find expression for time in using this first equation of motion. So this will give us t is equal to vi over a. We have already calculated expression for a is equal to g sine theta and vi is initial velocity. So this is the time which ball takes while going upward. If the ball starts its motion downward, this will be represented by t prime, and it will take the same amount of time, because again only gravitational force is acting, and mg sine theta responsible component is acting in this in downward case also. So we will write it vi over g sine theta. Our inclination length is the same and the gravitational force is the same, so time will be same, vi over g sine theta. So if want to find the total time, so the total time will be sum of these two time for upward motion and time for downward motion. So we add these two equations, this will give 2 vi over g sine theta. Okay, now we start to solve another question. A child slide a block of mass 2 kg along a silicon floor. If the initial speed is this and the block hits its spring with spring constant this, what is the maximum compression of the block? If block, for example, block is going with some velocity, it has mass, so definitely it will have some momentum and some kinetic energy. If it hits some spring, some parts of this energy will be utilized by compressing this spring. So this energy of this moving ball will be stored in the form of potential energy. So we can write and equate the equation for the kinetic energy of the moving ball and the potential of energy of the spring. So 1 by 2 mv square is equal to 1 by 2 kx square. This will give us we can find the value of x, because we are given spring constant, we are given the initial velocity and mass of the ball, and so we can find the expression for the maximum compressions. This is the first part of this question. Again he says that what is the result if the block slide across 2 meters of a rough floor that has kinetic friction 0.2. If the block starts to slide, so some part of this moving kinetic energy now will be utilized against to overcome the friction. So what amount of friction for sliding along frictional surface, some kinetic energy will be dissipated in the form of overcoming this frictional force. So the work for this frictional force will be F dot D, because he is covering distance, for example distance D. So F is mu into m, mu into n, mu n is mg and mu is coefficient of friction and D. So this work will be utilized to overcome the friction. So 1 by 2 mv square is total energy minus this energy which is utilized, and the rest of energy with remaining energy will be converted into spring's compression energy or potential energy, because some energy of this moving ball will be dissipated against frictions, and other energy will compress the spring, plus during compression again some amount of energy will be utilized in overcoming the friction of this springs. So if we equate these equation, 1 by 2 mv square is the total energy minus mu mgd is the work done which is used to utilize to overcome the frictional force, is equal to 1 by 2 kx square plus mu mgx, because during compression of the spring some energy will be also transferred to that also. So mu mgx, this mu mg is due to friction and x is the distance that the spring will, because if the spring is compressing, it definitely will face some frictional force, so some amount of energy will be also stored in that case. So mu mgx plus 1 by 2 kx square. So evaluating this equation for x, this is quadratic equation. If we use quadratic formula and want to find out expression for x, so this will become x is equal to minus mu mg plus this whole term. These all constant are given. If we put these values of constant, so this will give x. This is very easy question, so we just need to remodel this to this step. Another question, which is question 14, I have already discussed this question, but due to some reason this was not completely cleared in that recorded section, so I will again record it. If projectile is fired with initial speed v naught at an elevation angle alpha up a hill of slope beta, this is slope of angle beta at an, and we are firing the projectile at an angle alpha. If this total angle is here alpha and this is beta, so this will be equal to alpha minus beta. In the shortcut of class, in shortcut videos where I have discussed, in which videos I have discussed the tips and techniques, we have also discussed this problem and shortcut for this problem, problem also. So you can just go back and revise the short techniques for sketching this free body diagram. The first question is, how far up the hill will the projectile land? So we need just to find the horizontal distance that the particle will cover along the inclined plane in the first question. And in the second, at what angle alpha will the range be maximum? For what values of alpha our range will be maximum? As we have already studied that the range is maximum for the horizontal case at angle 45. So for the inclined case, this angle is not 45 but 55. So first we will find this, what angle, at what angle alpha the range will be maximum. So if we are given with the maximum condition of a maximum range, if we put that angle in our expression for a range, so this will give the maximum range also. So in the third part of this question, we need to find the maximum range. So let's start and analyze our questions. First, y is equal to x tan alpha minus 1 by 2 gx square over 2 v naught cos square alpha. This is the equation of incline of the projectile. We show that it is adopting some types of parabolic path. Y is equal to x tan theta. This equation we already obtained in the lower class, so I will not redrive this. I have directly written is y is x tan alpha minus 1 by 2 gx square over 2 v naught square cos square alpha. You can easily get if we just write x equation for x and then equation for right. If we find value of t from x and put into y, so this will yield this equation y is equal to x tan alpha minus 1 by 2 gx square over 2 v naught square cos alpha. This is just if you put value of t from x component of displacement for the case of projectile motion and put into y component of displacement, so this will give us this equation. So again, you know that x is d cos beta and y is d sin beta. This is if we resolve this inclined plane into inclination length into two components, the first will be d cos theta, which is along the inclined plane, and the second will be d sin beta. So d sin beta will be vertical component and d cos beta will be horizontal. So while horizontal we write x, so for x we will substitute the value x is equal to d cos beta, and in case of y we will substitute y is d sin beta. So if we put y is d sin beta here and x is equal to d cos beta, and again here we will need to put value of x is d cos beta, and simplify this expression for d, because we are seeking for a range d, horizontal distance of this inclined plane. This is the horizontal distance that the projectile will cover if he is projecting along the inclined plane. Then here if we put these equation equal to 0, the first case is d is equal to 0 and the second is this term is 0. This equation will be possible to equal to 0 if we put these equation. So first is d is equal to 0, that is not our interest, and the second, because we are not finding the minimum range, we are finding the maximum range. So maximum range, if we just arrange each term on the other side, so this will become d is equal to 2 into cos beta tan alpha minus sin beta, and this whole term. If we take some common and write tan alpha is equal to sin alpha over cos alpha, and multiply this outside term into inside with this term and with this, and simplifying we will take common 2 v naught square cos alpha over g cos square beta, and this will become a identity sin alpha minus beta. So from here we can see that we have obtained the expression for the horizontal component or range of the inclination, which is equal to 2 v naught square cos alpha sin alpha minus beta. And if you want to find the time for the inclination in this case, so definitely this will contain some term like 2 is equal to 2 v naught sine of alpha minus beta over g and some other term. So you should now write the expression for time of flight for the inclined case. We have obtained expression for the horizontal range. If we want to seek expression for the time of flight, so you should know that this should contain some sin alpha minus beta over g sin alpha or cos alpha. Now we are seeking for a maximum horizontal range, because our second part of question said at what angle alpha will the range be maximum. So if we want to find the maximum range, so use mathematical tricks. We will have to take the derivative of this d with respect to alpha and put equal to 0, because at maximum our rate of change is 0. So at maximum change, if we take the derivative of this d with respect to alpha, so this will give us this term. So we will definitely have to product rule of the differentiation. So if we take the product, apply the product rule of differentiation, first term derivative of second and the plus second term derivative of first term, this will give then again equal to 0, because we are seeking the maximum maximizing condition. At maximum our rate of change is 0. So this will give cos of 2 alpha minus beta is equal to 0. If we find the values of alpha, so it will be pi over 4 plus beta over 2. So this is the angle at which our horizontal range will be maximum. If put values of this alpha back to our initial conditions in this expression, so this will give us the maximum range. This is the maximum angle. This is the angle at which our range will be maximum. If we put these values in the first expression of d we have calculated, so this will give us 2 v naught square cos square beta, and this, so we just need to put the values of alpha. So this, if we use trigonometric identity, this 2cs is equal to sine a minus sine b, where a is this term and b is this term. So we can find out that sine pi over 2 minus sine beta over 2, sine pi over 2 is 1 and minus sine beta over 2. So if we write this cos square beta is equal to 1 minus sine square beta, so this further we can write as 1 plus sine beta and 1 minus sine beta. This equation can be written 1 minus sine and 1 plus sine. So 1 minus sine will be cancelled, 1 plus minus sine, and we will left with 1 plus sine. So this is our maximum range. This is the required expression for the maximum range. Now let's move to another question, which is question 14 of the Marion books, which says that a train moves along the tracks at a constant speed u. A train is moving on the track at constant speed u. A woman on the train throw a ball of mass, let's suppose consider m, straight ahead with a speed v with respect to herself. A woman which is in the train and the train is moving with speed u, and he throw a ball upward with speed v. So the first question is, what is the kinetic energy gain of the ball as measured by a person on the train? So in this case we will see that the relative motion between the woman and the train is 0. So Ti initial is equal to 0 because at and the some later moments, because now the ball, if the ball leaves the hand of a woman, the ball velocity will be v. So the final velocity will be equal to v. So its energy will be 1 by 2 mv square. So the change will be delta T is equal to 1 by 2 mv square over 2. We have put this Ti is equal to 0 because at T is equal to 0 the ball was in the hand of a woman and the relative velocity between ball and the woman's hand and the train was 0. So therefore at this case relative velocity was 0, so Ti was 0, and the final velocity, because as the ball leaves the hand of a woman, at this case relative velocity between the woman and the ball is v. So we have to put v. Tf is equal to 1 by 2 mv square. So the difference will be delta 2 1 by 2 mv square. And then by a person standing by the railroad track. So for the outside observer, because he is observing from the outside, so he will take into account this velocity and this velocity, because as he throw the ball, she will throw the ball, she will move forward and the ball will fall behind him. So in this case this velocity will not u and this velocity will not u and this velocity will not v for the person outside. So Ti initial velocity as measured by the outside observer, we will take into account the relative velocity. So in this case 1 by 2 mu square initial velocity and final velocity will be v plus u square, because for the outside observer this will be a contribution of these two v and u. So we will write a v plus u whole square, relative velocity between these two balls, v minus u because velocity in this case will be negative, so v plus mu. So if we write the change of this, so delta T will be 1 by 2 this velocity minus this. So the one term will be get cancelled and we will left with the other two term, 1 by 2 mv square plus mv u. So in this case our relative change in will be delta T, which is 1 by 2 mv square plus mv u. Then another question, how much work is done by the woman throwing the ball? So we need to find the work done. The work done by the woman will be 1 by 2 mv square, because the kinetic energy that was with respect to woman of the ball. So just we will put equal to that 1 by 2 mv square. And by the train, the how much work is done by the woman throwing the ball, and by the train how much work is done by the train, because train was moving with velocity u. So this work done will be force multiplied by that distance, so mv into u. So work done by the train will be this. And this was just a simple question. we have to take into account just the change of the kinetic energy between the two frames, as in the first case, in the second and the third. Similarly, another question: a particle is under the influence of this force. K and alpha are constant, at K is also positive. Determine U of x. So we are given with the force. If we want to find the potential energy, so F is equal to minus. So if we recall that force is equal to rate of change of potential energy, so we will integrate this expression. F is equal to minus delta U over delta x. If we want to find the delta U, so we will definitely integrate this equation. F dot dx will be equal to delta U, and U of x is equal to F dot dx. F force is given, so if we integrate this equation, this will. So we know that for small x, our this term will be dominating. As the values of x increase, so this subtracting term will be dominates for higher value of x. So for large x, the behavior is determined by the term which has greater contribution. So minus kx 4 over 4 alpha square. So for the smaller value of x, our term will be like parabola, and for higher value of x, this will be like hyperbola. So minus k over 4 x 4 over alpha square will be the determining factor of which determine the shape of that path. Another question is, what happen when E is equal to k over 4 alpha square? So we find the value of x by setting du over dx is equal to 0. If we find the rate of change, if we put this is just like we are putting the force, external force is equal to 0. So du over dx is equal to 0 means that our applied force is 0. If we consider this, so F is equal to du over dx, which is equal to 0. In that case, our because we are seeking for just equilibrium point. If force at any point is equal to 0, it means at that point no force is acting and our body will be equilibrium. So du over dx, putting this equal to 0 means we are seeking the equilibrium point, or F is equal to 0 means we are seeking, it has the same meaning. So in this case, we have put du over dx is equal to 0, and we are given u, so we just need to take this derivative and put equal to 0 for finding the equilibrium points. So this will give us the value of x at which our particle will be at equilibrium. So this will give the value of x is equal to 0 plus minus alpha, or the equilibrium point. So if we are interested in finding the value of potential energy at that equilibrium point, so if we put the value of x one by one, first for x is equal to 0 and the second for x is equal to plus minus alpha, so we are given potential energy at plus minus alpha will be equal to, for plus value it will be alpha 1, and similarly for the second E2, so the first equilibrium point and the second equilibrium point, and x is equal to 0 is also will be an equilibrium point. Another question which says, describe how to determine whether an equilibrium body is in stable or unstable equilibrium when d square u over dx square is equal to 0. So this is question 45 of the books. In the lecture we have already discussed that we can expand the potential energy about the equilibrium point using the Taylor series. So we have just write this Taylor series in the compact form. U of x is equal to sum of I is equal to n plus 1 to infinity 1 over I factorial di over dxi and xi. If we just expand, so this will become the Taylor series, and we have already discussed in the one of the lecture also the leading term in this force. If we write to if want to write this potential energy in term of force, so f of x will be equal to du over dx. If we change the derivative, so this will give minus 1 over n factorial d power n plus 1, because this n will be the power of x. So n, the force is restoring force for a stable point, so we need that f for x greater than 0, f should be less than 0, because we know that if we right expression for restoring force. So it is just like F is equal to minus kx. If x is positive, so force will be negative for restoring for stable equilibrium, because if we slightly disturb this particle from this position, so for restoring force will be the responsible force which will again push this particle to its returning point or initial point. So if we take this particle from this point to this, again restoring force will act and it will come back. So in this case our force will be proportional to minus k time of some x. So if x is positive, our force will be negative. If x is negative, force will be positive. So he says that the force is restoring for a stable point, so we need x should be greater than 0. For that, force will be less than 0, and if x is greater than 0, force will be less than 0, and for x less than 0, force will be greater. This is never true, because for this case, when n is even, u will be equal to kx cube, and this is the tricky point, so I will just elaborate this. If I erase this, so I will be able to write the further detail on this. Here he says that this case, this is not an equilibrium. When n is even, you know that if u is equal to k x square over 2, so if k is x square over 2, here this is even. If we write to for force, if we want to find the force, so F will be equal to minus du over dx, so F will be equal to minus kx. No, here the x, the power of x is even, so in this case the power of this x is odd. So for the odd case, we have an equilibrium point, we have a stable equilibrium for in the force. So here we have f of x is equal to proportional to x power n, where n is the power of force. So if this n is even, it means our body is not at its stable equilibrium. If this n, which is the power of displacement in the expression of force, if this is odd, so our body will be in stable equilibrium. So if we are considering the potential energy expression, if we contain even power of x in the expression of potential energy, like kx power 4 over 2, kx power 6 over 6, 2, and similarly even power of x in case of potential energy, so that will be a stable case. But for force, if we have odd power, this will be stable. If we have even power of x, so we will have with definitely unstable equilibrium. So this is the point which we need to understand. At this point I will stop here, and again if some we have left the problem, again I will definitely solve for you.